Hi, welcome. Good afternoon. So I'd like to introduce our speakers today. Chris Crome with Docker, Michael Irwin with Virginia Tech, and welcome to Deploying Distributed Applications with Docker App and CNAB. After the talk, we should have a little bit of time for questions, and if we go over, we'll take them in the hallway. Thank you.
Good afternoon, everybody. Hope lunch was good and everybody's doing well. So just to, again, to introduce ourselves real quick. So my name is Michael Irwin. I am from Virginia Tech within the Central Division of IT. There I'm an application architect, and we've been playing with cloud and containers for about 4 to 5 years now. So I've been playing with containers for quite a while. I also a Docker captain. For those of you that might have been in the Containers for Beginners talk, I also did that one. And I'll go ahead and just say too, I found out I was doing this talk about 45 minutes ago. The original speaker is actually sick today, and so I'm filling in for him. So bear with me as we go through with this. And I'll let Chris introduce himself and let him take it away from there.
Yeah. So hi everyone, I'm Chris Kroner. I work on the application definition team, and we're responsible for Docker apps, so some of the CNAB stuff with Microsoft folks and others. We also work on Compose and Kubernetes, Compose, and Assemble, which is some of the things you saw in the day one keynote. So today we're going to look at a couple of things. So we're going to start with an introduction to CNAB. It's one of the buzzwords at the moment, so I thought it would be good to take some time to just explain what it is and why it exists. I'll introduce the specification, but I won't go into too much detail. I'll just be talking about the very basic parts of it. I'll then introduce Docker App, to show you what that is at a slightly deeper level than what you saw in the keynote. And then Mike will take over afterwards and talk about the lifecycle problems that companies face and do a quick demo showing Docker App and how it solves all of that. We will have some time for questions, I think, so stick around. So CNAB stands for Cloud Native Application Bundle. And before we can really dive into that, and what CNAB is, it's good to ask the question, what is an application? So we can start with the OED definition, a program or a piece of software designed to fulfill a particular purpose. That kind of feels very loose and a bit like a cop-out. And I like to think of an application as something that solves a user problem. So, we're at a tech conference. Let's try to do a little bit better than that. What is an application really? Is it a binary running in a virtual machine? Is it a binary running in a container? I mean, we are Docker after all. Is it multiple containers orchestrated by Kubernetes? Yeah, that's okay. A hosted database and some lambdas? Or any combination of the above? Well, it's obviously any combination of the above. And actually, if you ask 10 people, you'll probably get 10 different answers. And that's kind of the point. So that then pushes the question of, well, how do you deploy an application? And once again, it completely depends on how you built your application, because an application is such a personal or such a specific thing to your company. So the container part may require Compose and Docker Stack Deploy, or Kubernetes and Kubernetes, or kubectl and kubeyaml. You may need Terraform to deploy infrastructure. You may need AWS, the AWS CLI to set up load balancers. You may need a whole lot of things. And of course, each of these have their own packaging system, which means that it's a complete nightmare whenever you want to deploy your application. So that's how we got here. This is the CNCF landscape. It is a bit crazy, but it's a good thing, not a bad thing. It's good because different problems have different solutions, and therefore you may need different tooling. And acknowledging that, I think, is a key aspect when you're talking about applications. It does make managing and deploying applications a complete nightmare for us, though. So there are lots of different development tools and packaging systems and deployment tools, and that just lands up with us having these complicated tool chains with multiple tools, and then you have the tool chain versioning problem with which version of the tool do you need to use to deploy your application. So what is CNAB then? Well, it's yet another acronym. It stands for Cloud Native Application Bundle, where Cloud Native is that landscape I showed before. It's basically all these technologies that, including containers, lambdas, hosted infrastructure, it's all of that stuff. Application is what we tried to define earlier, which seems to be basically, depending on who you are, something completely different. And bundle is just a way of packaging this stuff together in a way that it's easier to manage. So it aims to be a packaging format for distributed applications. It's a specification, though. So the target audience is tool developers, not end users, really. So what are CNAB's goals? Well, the first goal is to deploy complex applications easily. As I showed you earlier, depending on how your application is constructed, it could be really complicated to deploy. It wants to be cloud agnostic. It doesn't want to have very strong opinions about where it's running and why and how. It wants to be secure, because we live in a world where this is a real problem for internet companies. And it wants to handle a spread of use cases. And by a spread, I mean things like air-gapped environments, IoT, run on your laptop, run in the cloud, run everywhere. So in essence, it wants to be one format to rule them all. So right about now, all your alarm bells in your head are ringing. You've probably seen this XKCD comic before. Surely yet another specification is not the answer to this problem. But I'd like to assure you that we're not creating CNAB alone. We're working with Microsoft. Jeremy's sitting here, one of the people from Microsoft working on that, but NAMI, HashiCorp, Pivotal, a bunch of other people, actually. And what's great about this is it's being done in the open. You can come to the community meetings and meet the people who are designing this by people who all have different goals and who all are building different tooling around this. And we think that's going to bring us to a place where we have a specification that is actually used by everybody and works for many different use cases. So how do you go about this then? Well, the first thing we need to do is take a step back and say, what is actually common for applications? So we want to find some commonality. In every application, there's a definition. So in the compose world, this is a compose file. In you could also define an application in Kubernetes YAML. There's a bunch of other options as well. The second thing is you need some tooling. So this is the thing that reads that definition and deploys the application. So in the compose world, this is the Docker stack command. So you can do a Docker stack deploy with your compose file, and that'll deploy it. kubectl can be used to apply kubeyaml, and so on. Helm, for example, is another tool that will handle this. The next part for every application is a set of parameters and credentials. So the parameters are the knobs and levers you can pull at deployment time. These are things like ports, labels, things like that. And the credentials are the things that you need to deploy the application. This is the key that lets you talk to the API or whatever else you need to do to deploy your application. The other thing to consider is we're probably not the first people to do this. And that's a common theme in computer science. It's one that people don't think about enough, but maybe we should take a step back as well and say, where else have we seen these problems, and where can we reuse concepts? So we have this notion of a container. It's defined by a Docker file. You can build an artifact from this, an immutable artifact called an OCI image, and you can share these with OCI registries. So can we map something like this onto applications? So the definition is going to be tricky. As we talked about at the beginning, everybody has a different idea of what an application is. So the definition part's probably not a good place to try and do that. But can we wrap applications as OCI images? And can we share them with OCI registries? Those are questions that are really important. So diving into the spec a bit now, it's broken up into multiple pieces. And we broke it up so that we could work in them in parallel and try to get to something that was workable more quickly. So the first two pieces that are interesting are what's called the bundle definition and the invocation image. And I'll dive into each of those, just not too deep, don't worry. So this is a snippet of a bundle definition. So it's a JSON file. This is read by a runtime tool, something like Duffel, which is the reference implementation, or Docker App, which is a CNAB compliance tool. Anything that's CNAB compatible will be able to read this. The top piece is the metadata. So obviously, every application needs a name. It needs a version. It needs a description. You probably want a list of people you can shout at if it stops working. We call those maintainers, and so on. We then have invocation images. The invocation image is actually an installer. And so in this case, you can see I have a reference Docker image. The specification is loose, though it could be something else as well. We have credentials. So in this case, we have a kube config. And then the path is the place it will be mounted into the installer to be used. And we have parameters. Here's an example of a port. What's great about the parameters in CNAB is they're strongly typed. They have default values, minimum values, maximum values, regex, and so on. So you can do some error validation with them. So onto the invocation image. So this is essentially the installer. It contains the tooling and the application definition. So that way you have one unit that contains both, which means you don't have to worry about versioning or anything like that. It makes it a lot simpler, especially when you have multiple tools. It has a very well-defined directory structure because it's a container. So we have inside the /CNAB directory, we have a /app. Then we have, in the Docker app case, an application definition there, which is a .docker app, and a run, which is the entry point. The run command here also contains the Docker app tooling, but that's not necessarily the case. You could write literally a bash script that does something if you'd like, and it would be a valid invocation image. So the well-defined entry point is CNAB app run, and that expects a bunch of standard actions. These standard actions are things that every application needs: install, uninstall, upgrade. Those are the only standard actions. But you can extend the actions using the bundle definition and say what other actions your application supports. So parameters and credentials are injected at runtime. So when you do the deploy, it creates the invocation, or it creates a container from the invocation image, and then injects the credentials and parameters into that so that the installation can take place, or the upgrade, or whichever other action you'd like to do. So what about CNAB for end users then? Because I think most people here are end users. As I said at the beginning, it's really focused at people who make tools. Well, it's simpler deployment and management of apps. And that's the whole point of this. It just takes away all that complexity when you have really complicated apps. We're aiming to have a common storage format, which means that we can have reuse. This is something that we've all been dreaming about for applications. Basically, we have the same thing for containers and container images, where you can reuse existing ones. We want the same thing for apps, because we don't want to do things twice. It also brings compatibility across tools. And what that means actually is you get to use the tool that you like best. So Docker app is a CNAB client, or a CNAB compliant client. So we're going to take a quick look at what that looks like from the Docker perspective before I hand over to Mike. So what is Docker app? Well, it lets you create compose-based applications. It lets you share these applications using container registries. And it's a CNAB compliance client. This means that if somebody else creates a CNAB with their tooling, you can install it and manage it with Docker app. It abstracts CNAB away from you, because as I said, the important thing here is that CNAB gives us a lot of power, but we don't want you writing CNAB bundles. It's too complicated. So a Docker application definition is basically broken up into 3 parts. This is how you define your application. We have a compose file in the middle, which is what many of you will be familiar with. And that lets you define a list of services, volumes, networks, secrets, things like that. It's a great format for defining your application because it's really simple. But it was missing a couple of parts. The first part it was missing is metadata. So what is this thing called? What is its name? What is the version of this thing? What is the description? And finally, parameters. Parameters are a mechanism to communicate between developers and ops of what can be changed. So we have another section, which is the default parameters. So why Docker app? Well, as I said, Compose is a great thing for defining applications because it lets you define services really easily. It's not as verbose as kubeyaml and things like that. It provides a simple way to share applications as well, which is something we didn't have. We're reusing container infrastructure, so container registries and images to share applications, and that's really powerful. It allows you to add metadata to describe the application, and you can communicate what changed on install. So it facilitates that dev to ops handover, which is so important because if you don't have something like parameters, the developer writes a compose file, the operator has to read that compose file, and that's really not what you want. You want them to have an easy way to understand what they can change and what they shouldn't. And with that, I'll hand over to Mike, who's going to show us. We'll talk about the lifecycle problem and give us a demo.
Absolutely, thanks, Chris. Great overview. I mean, so CNAB a fantastic spec, and it's fun to see it evolve and grow over the last little while. And so I've been excited to watch Docker, Microsoft, and others working together on that spec and seeing how Docker App has become much better in the process because of it. So Docker App does work really hard to solve several different lifecycle problems with application life cycles is specifically what I'm talking about here. So kind of traditionally, a lot of our applications have had a similar architecture where we have a monolithic application that connects to a single database, and this is traditionally how we've done things. And if I need to deploy another version of the application, I'm spinning up this entire stack every single time. And since monolithic applications, we don't make those very often, it's okay to take the time to spin up the entire stack, and we just build that into our timeline. But this gave us great segregation. It was fairly easy to set up additional environments because it's just one app, one database, not too bad. We probably don't do it too often, et cetera. But security, now we've got a single target for everything. And so we need to harden and protect this thing. And again, databases are usually always the hardest part. How do we set up the database? How do we know the right scale for this monolithic application, et cetera? And how does it vary between dev, pre-prod, prod, et cetera? We may have different sizing constraints, different I/O throughputs, et cetera. So how do we parameterize each of our different environments? And now as time has evolved, now we've got newer problems. Everybody's like, yeah, break up these monoliths and all of your dreams will come true. And it's like, wait a second. Now we've just added more problems. Okay? So a lot of people say, well, yeah, I'm going to break this up and I'm just going to split my front end from my back end and that'll be good enough, right? Then I can iterate my front end, and as front end bugs come in, I can update that and deploy it out. And for the most part, it's a very similar architecture, but we haven't really gotten to the microservices idea, and we still have a monolithic backend, and this is still really common. Okay, but again, we've got separation of responsibility. Now we've got UI front-end code that's mostly standalone, and then we've got APIs that can be tested and everything directly through API clients. But again, we run into the problem of how do we set up all these environments? How do we vary them between environments? How do we instrument the front-end application to know what back-end it's talking to, et cetera? There's a lot of these parameters that change between all the different environments. And for gaming the system, some engineering cheated. In many ways, engineers find a way to game the system however they can, okay? And some deploy Nginx and Apache proxies as frontiers and end up just leaving the same monolithic in the back-end. Yeah, we've just added another layer to the system. We're now microservice, but we're not really, okay? Everything's still going to the normal backend, okay? But now, there we go. Now once we actually do break things up, now the problem is just bigger, okay? So how do we keep track of all these different microservices? What versions are being used where and when and all this kind of stuff? How do we connect them all together? Sure, it dramatically simplifies development because as a developer, I just say, hey, I need to fix this part of the system, all right? That's part of that microservice. I don't have to worry about the rest of the entire stack. Sure, again, it makes things much easier as a developer, but now it's an ops problem, okay? And so how can we help out with that transition and security? Okay, now you've got lots of different endpoints that you're having to protect. How do you know, in this case, for example, messaging is talking to email, but maybe we don't want payments talking to email. How do we make sure that only service-to-service communication is what we want? Okay, and again, this is hard. Okay, and so Docker App is working towards helping make that easier, so that as ops and developers working together, we can have a single compose file spec that we can use everywhere, and then we can parameterize and change based on local development needs or production or staging or whatever else our needs may be. At Virginia Tech, actually, our team's been using Docker App for about 8 months. No, it hasn't really even been public for 8 months yet. Pretty close to 8 months anyways. So soon after it came out, and it's completely changed our development environment. And I'll show some of those capabilities here in a few minutes too. So again, the modern lifecycle systems, we've got different OSs and languages. They're really complex, and All right, Docker helps out with that because we just have a container. That's our standard unit of applications, and we can just ship that around. Upgrades, okay, in the past we had to patch machines, and that was just really complex. Now it's, here's a new container image, just run it for me. Management, how do we document, orchestrate, package these things? Again, containers help out, and Docker App provides another packaging structure, another way to share what works across all of our environments. Okay. And again, so for upgrades, you see this is going from a version, for example, 2.0 to a 2.1. I may have to update lots of different pieces, or even just flat out add services. In this case, you see the green boxes are new services, and the orangish yellow boxes are updated services. Managing this can be quite difficult, but if everything's in a single compose file, well, I just do my deploy and out it goes. And I can validate that during development. I can use that same compose file when I go to production. So with that, enough talk. Let's do some demos. And again, like I mentioned, I started this about an hour ago now, and we'll see how these demos go. So bear with me if we end up having to do some troubleshooting along the way. That's always good too, because it's good to see how can things go wrong, how do we fix it, how do we think about the problems, etc. So here goes. What I'm actually going to do first is I'm going to mirror my display so I can look off of here real quick. Boom. Okay.
Just mute your notifications.
Yes. Gather windows here. Okay, I'll just do that. Nobody wants to see all my Slack messages. All right, there we go. Okay, so for my example here, I'm going to be working with the Docker example voting app. How many people are familiar with the voting app example? Okay, so there's a couple hands, that's good. All right, so just quick overview, quick architecture of this application. Go down to the picture here, there we go. Zoom out just a little bit. So this application, it's super simple, completely over-architected, but that's okay. It helps us visualize what's going on here. So we have a simple little voting application, which in this case is a Python-based container. I can vote option A versus option B. At default, it's cats versus dogs. Dogs are obviously the better winner anyways, but you can still vote for cats if you want. So I can vote, and the votes are put into a Redis pub sub queue there. And then from there, a .NET worker is pulling the messages out. And then the .NET worker says, cool, I got to vote for dogs. I'm going to put that in the database. We should probably just code it to say if you do cats, that also goes for dogs too, but whatever. And it puts it in the database. And then we have a results app that then reads the results and provides a web UI for it. Okay, so fairly simple, but there are various pieces going on here. And let's jump over here. Oh, forgot to remove that real quick. Okay, so I've got a Docker Compose file that has this stack. So we've got Redis, we've got the database, we've got the vote and the result services and worker, et cetera. So basically just what we saw there. And now if I want to make a Docker app out of this, make this full screen here. All I have to do is do a Docker app init, and I'm just going to call my new app voting app. And by default, it's going to use the Docker Compose file that's in my directory as the compose file for the app. And with that, it says, well, it created my voting app.docker app. And you'll see that a new directory has shown up in this directory called voting app.docker app. And if we open that up, we will see the Docker Compose file, which is the exact same one. It just copied into this directory. And we also see the metadata and parameters file that Chris was talking about earlier. So let's actually look at that real quick. So the metadata just has a version number, it has the name of the application, description, I can put maintainers and other kind of stuff. So it's just arbitrary metadata that gets carried along with the application. And the parameters file just starts off with an empty object, but in a minute we will add parameters to see what that looks like. Okay. All right, so I've got this app here, and actually I can do a Docker app inspect just to see what this looks like in, oops. Oh,
context.
Yep. Okay. So let's inspect this local voting app here, and this is basically reading that compose file, and it provides a little more friendly approach to what's in this application. So instead of an ops person having to go through and read the compose file and pull out, okay, what services are here, how many replicas, port mappings, what images, all that stuff, it just gives you a little bit more friendly approach to this. It tells me the networks, volumes. If I had parameters on here, I'd see that as well. Okay. So what I'm going to do now is I'm going to push my Docker app. And so I'm going to push voting app, and I got somehow magical access to the Keynote EE cluster. So we're going to push to that EE cluster and break everything, right? And so what I'm doing here is I'm doing a Docker app push, and I'm going to tag it for the registry, and I'm also specifying the platform. I know it's word wrapping there a little bit, but for just time's sake, I'm just going to target a AMD 64 platform. By default, it's going to use whatever architectures are available. So it's going to look at all the images. There we go. It's going to look at all the images and all the different architectures for each of my images, and we'll push them all for all that are available. So if I made ARM images for my application, it'll push those and make those available in the app as well. Okay. So let's run that. We'll see it start up. And since I pushed this earlier, you see it doing a lot of skipping. And that's because we didn't want you to just sit and watch it push layers. So, all right, at this point, we see the bundle has been pushed, and I can actually go over to the DTR now, and let's go to my app demo, and we'll see the Docker app, and if I go to tags, we'll see that latest was just pushed 21 seconds ago. Okay, so live demo, it pushed. Hooray, it worked. Okay, so now what can I do with this? I've pushed the app, and so at this point, anybody that has access to this repository in DTR has access to this application and can deploy it. Okay, so let's go ahead and deploy it to our Swarm cluster. Now there's a command coming in the Docker 1903 release called Docker context, and so what I'm going to do is I'm going to use that. In fact, I'll just show, I've got a default context. I know this is wrapping like crazy right here. The default context is just pointing to my local machine, but I've set up another context which is pointing to the UCP cluster. And what this allows me to do is basically change my engine, so now all the commands that I run are no longer running on my local engine, but against that remote engine. And so if I do a Docker node ls, for example, I see all the nodes in the cluster. So now any commands that I run are running against that. Which actually, I guess I don't have to switch context, but whatever. Okay. All right, it's fun to show. So let's do my install now. Yep. Okay, let me grab the. Okay, so if we look at install, we'll see various parameters here. So I have to give it an app name, which is going to be the registry, the full registry URL to the app. And I can specify a shorter name, and I can specify a target context. So I could use my just local default context and say, actually, I want to target and actually deploy into this other location. So let's do a Docker app install, and let's let it go.
Yeah, so in this case, it's installing on the UCP because it switched its context before. So if you set a context, it uses that one across multiple terminals. This is much nicer than the environment variable flow we had before.
Yeah, so instead of having to source that env.sh file, if you've ever worked with client bundles, this is the much newer, better, cooler way to do it. So if I jump over to UCP now, what I should see, let me go back to services here, refresh. Okay, we should see services, and okay, this one's still working on spinning up, but I see that my voting app, it created the services, it deployed the stack and everything, and unfortunately, due to the firewall rules and everything, we can't open the app because it's on crazy ports and all that kind of stuff right now. But we see the services have been created and it's up and running now. So hooray, it worked. Okay, so what else can we do with Docker app? Let's go ahead and just uninstall real quick. That's probably failed to remove network.
Try again.
Yeah.
Just install with a different name. There you go.
Okay. Yay. All right. Just if it doesn't work the first time, just try it again, right? All right. So I talked about parameters for a minute. Okay. And so what sorts of things can I parameterize? Or really, in the compose file, you can pretty much parameterize everything except for the image names. Okay. And there's a whole conversation on GitHub about that right now. So if you want to chime in on that conversation, feel free to argue all day you want. But so I can parameterize really anything in this file. So for example, can I?
No, you can't. And the reason for that at the moment is that we want to tie a list of images to, or list of service images to an application version, or else the application version is a bit fuzzy. The way we want to try and get around that is maybe using build arguments. So when you build the Docker app, you can set the image tags. It's just we felt like the version of the application needs to be tied to something, or else it's just it doesn't mean anything.
Yeah. So that way, every time I deploy 0.1.0 this app, it's always going to be the same images. You don't want that to be flaky there. Yep.
But there's definitely a use case there, which is why there's this very vibrant discussion on GitHub.
Vibrant. That's a good name for it. So what I'm going to do is I'm going to make a parameter. I want to change the exposed port that this is on, and we'll just start here. And so all I need to do is it actually looks very similar to just using environment variables when using local compose. And so what I'm going to do is I'm going to say vote.exposedPort will be my parameter. And let's just start there and let's see what happens here. If I do a Docker inspect voting app, it's going to complain to me. Let me switch my context here back to local. It's going to complain and say, hey, you've got this parameter, required variable vote.exposedPort is missing a value. So if I specify a parameter, I have to give it the default value. I can't just say, hey, this is a parameter and you have to specify this at deploy time. It has to have a value, a default value. So what I'm going to do is I'm going to go into the parameters.yaml, and again, since this is a YAML file, I can use YAML structure, and I name the port vote.exposedPort. So for my parameter, it's going to be vote.exposedPort, and if I leave it at 5,000, which was the default beforehand, then that should work. I'm going to go ahead and do the same thing for the results, and that was on 5001. I'll update the compose file. Let's see, where's result?
So this is also the process that an ops would have to go through if they wanted to change the ports. They'd have to read this compose file and find the ports that they can change. And that's something we're really trying to avoid here. The developer knows the application. They should be setting this up.
Yep, absolutely. And again, we can parameterize everything. We could say, all right, here's the number of replicas for it, or the parallelism. I can set the CPU limits, memory limits, all that kind of stuff. Anything you can define in a compose file can be parameterized. And now if I do my inspect again, what we'll see is it's added the parameters down at the bottom for 5001, 5000, and I'll see still those ports there. It's again the default values. But let me actually set a value. So vote.exposedPort, and give me a number.
Quadruple 9.
Quadruple 9. Man, you guys weren't very fast. I'm just saying. Okay. So now we see vote.exposedPort, that parameter has it, and we would see that the service vote would also have that same value. So let's, for kicks, go ahead and do a Docker app. Actually, let's just pull it up from before. The install. I'll set the target context since I didn't switch to UCP. And let's set vote.exposedPort to your quadruple 9s. And, oh, because I didn't push.
Yeah. So what the push does is it pushes all the images required for the application into the same repo. And the reason we do that is because it means that if you have access to the root application, you're guaranteed to have access to all the images. Another problem with compose is if you just have a string inside a file, how do you know that image actually exists? So by pushing them all into the same place, you simplify RBAC, and you guarantee that you have everything you need for the application. So it's just this one atomic unit that can be moved around. It's also great for the DTR promotion flow, because if you push an application after it's been tested into, let's say, staging, you can promote it to production as one atomic unit, and that's a really powerful notion. We have the same thing for images and containers.
All right, so we're doing our install. We set the exposed port to 9990, and if I do a contact use now for UCP, let's look at our services. And let's see, we changed the vote port. And so let's do a service and spec. I could do this through the UCP panel, but I'm a nerd, so I'm going through the CLI. And I'd see that the published port is 9990 for on the cluster. So just one other thing I'll just demo real quick, and then we'll close up for questions. So on the Docker app command, I can actually create a CNAB invocation image and the bundle. So Chris showed off the bundle.json earlier, but if I do a Docker app bundle, switch back to local. Okay, I'll have a bundle.json created here so you can actually see what that bundle.json looks like. And so here's all the images and actions and et cetera. So that's the CNAB bundle JSON that's being shipped with the application. Pretty awesome. Okay?
Yep, that's great.
Sounds good?
Yep.
All right. Hey, the demos worked. Now where do the slides go? Yay!
So we got a couple of moments for questions. If anybody has anything burning questions.
There we go.
I have to duck out in like 2 minutes because I have to run to.
Okay.
Hi. So if the deployment that you're doing requires things like particular sequencing or requires a deployment strategy like a canary or AB kind of rollout, is there a way to express that inside of a CNAB bundle?
CNAB itself is completely open in a generic spec, so you could imaginably do that. It requires tooling to do that. So in the case of this, it's compose and Docker stack deploy in the background. So we need to evolve that spec to make that happen. CNAB itself is super, super generic. It's really just a definition and some tooling. So you could do all kinds of things like that, and that's the power of it.
Yeah, so built into Compose, there's nothing that does it yet. The depends on really doesn't help out with that timing kind of thing, as you probably already know at this point. But
yeah, if you'd like to see other CNAB content, though, we have a bunch of other talks that are happening. I'm just going to leave that up there while we're doing the questions. Yeah.
Awesome.
I have to run, yeah. I've got 2 minutes, it'll be okay.
You can stay on, right?
Yep.
I can stay for a couple minutes.
Okay. We have a few more questions.
If I don't know the answer, I'll just refer you to Chris.
Yeah, I'm C. Crone, CCRONE on Slack if anybody wants to ask questions. So.
What supports CNAB up to now? What can I deploy to?
What can you deploy to? So, well, Docker app, you can deploy to Swarm or Kubernetes clusters. But yes, CNAB, again, CNAB itself is very generic, and so it really depends on what the application bundle is designed to deploy to.
Yeah, so Jeremy's here. He comes from Microsoft. They're working on a tool called Porter. And the idea of that is to allow you to deploy different things. They have mixins, so you can deploy to, say, for example, your containers to Kubernetes. You can spin up a database on Azure. You can do a bunch of things like that. So this is the power of CNAB. It's basically like an MSI for the cloud or an RPM for the cloud. It lets you write an installer or have tooling that writes an installer that can set up any type of application. So at the moment, it's young. The spec is still being built by us tool builders. But what's super exciting here is this we can do anything. I know it sounds crazy, but it's with the right tooling, we can create these really complicated apps.
So according to the time, I still have 1:20. So I want to show off just one other thing real quick. So with our compose files, one of the things that's really cool with Docker app is it supports supports extension fields. And so what I can do is I can specify parameters to say, hey, is this a service that should be enabled in this deploy? And if I do a Docker app inspect, but I set the vote enabled to anything that's falsy, what we'll see is that service is no longer in the deployed collection. It would not be deployed in the service, or it's not a service that would be deployed. And so we use this all the time in local development, in which I have my Docker app that has all of my applications, latest versions of everything. But you know what? I'm going to do development on this one service. So let me do a Docker app deploy locally, but exclude this one service, and then I'm going to go to my component repo for that one service, and I'm going to do a Docker compose up. It spins up a dev container, but hooks into all the same networks and everything that was there. And so now I have the latest versions of everything but then I'm using a dev container for that specific service. And it's completely changed the way we do development. And it's awesome. So there's another cool feature that comes with Docker App as well.
Thank you much. And thanks for doing the talk. I was really curious, can you contact Docker Swarm and get back that bundle JSON once it's been deployed?
Well, so the bundle JSON is bundled in the image itself. So you technically can pull the Docker app image, extract the bundle JSON out from that as well at any point.
So it's got the specs built in, or?
Yeah, I mean, the specs bundled with the image itself. Yep, absolutely. Absolutely.
I'll just talk for a while longer.
Absolutely. Well, thank you. If you've got more questions, feel free to come up. Otherwise, you can look me up. I'm probably on Twitter more than I should be sometimes, and I'm pretty easy to find. So thank you. Thanks for coming.